Hello guys, welcome back to this series of tips and tricks in C++. So today we are going to discuss about the reference variables. So we'll see that what are they and how they work. So reference variable. Suppose I have this variable int a is equal to 10 and I just want to store the address of this variable so that my pointer should point to this location where the a has been stored. Then what I do, int asterisk p is equal to a address of a, right? So this is what I do, and if I want to print it, then I do something like this: printf percentile d and asterisk p. Means I need to use this asterisk to dereference the variable, pointer variable. So after that only it will be able to print 10, right? Now what I need to do, I do some change. Int asterisk const p, just before the name of the pointer I use the word const. In that case, what will happen if I do something like this: p is equal to address of b. I need to declare one more variable here. Int b is equal to 20. Then what will happen? It will give me an error at this place. P is equal to address of b, right? Because now it has become a constant variable, a constant pointer. But if I do like this, then it is not a constant pointer, so it will allow any pointer to point to any other location, right? So this is not giving any issue. So const int asterisk const p, it makes p as a constant pointer. Okay, so in this case, it will give you an error. When we talk about the references in C++, this is what we have to understand, right? So in case of C++, the reference variables are created like this: int reference of p is equal to a, right? So how this is converted internally? It is converted internally like this: int asterisk const p is equal to address of a. This is what happens in case of C++ references. So this is the reference variable, right? So this is referencing to a. When we create a reference variable and if we want to print it, then we don't need to use any dereference operator. We simply write like percentile d and provide the name of the reference variable, and you will be able to see the result. So it will print 10, right? So when you use a reference variable, then it automatically converts into the address reference of p, right? Internally it will convert, it will dereference itself to which it is pointing, right? So if you have written like this: int reference of p is equal to a, then in that case it is pointing to a variable a. Okay, so when we are creating a reference pointer, in that case you cannot do something like this: reference of p is equal to b. You cannot do like this, or you cannot do like this: p is equal to address of p. If you will do this, invalid conversion from int asterisk to int. You cannot do this. You cannot put cannot use this p to point to some other variable. Okay, if you will do something like this, then it will allow you, but then the purpose of having the reference variable will be lost, right? This is not the way to use the reference variables. Once our reference variable is started pointing to some variable, then if you will use again it for some other purpose, then in that case that reference will be of no use, right? So reference variables can only point to one variable at a time. So basically when we create a reference, then what we are doing, we are creating a different name. In a layman terms, you can say that we are creating an alias or a different name for a variable which is already there, right? And internally it is converted like this, right? And that is why if you do something like p is equal to address of b, or if you want to assign it to someone else, then it will not work. All right. So again, when you print it, I already told you that it will be dereferencing itself. There is no need. And if you want to create a pointer to a variable, sorry, a reference, then in that case, if you try to create address of p, then what will happen? This pointer will point to the address of a. This p is nothing. This p is pointing to this location. the location where A is there, right? So to show that, if I print the address of both the A and P, then in that case, the address of both the A and P will come same, right? So percentile U and slash T and then percentile U. Percentile U means unsigned, because address is unsigned, so I'm using the percentile U. So I'm just going to put the address of P and A, right? So P is the reference to A. So basically P and A both are pointing to the same location, right? So if you write like address of A or address of P, both will be pointing to the same location. So both are actually pointing to same location. So both are the aliases, which means that P is just another name of A, right? So if I run this and if I print the address of both the variables P and A, then both will come same. You can see both are same. If we'll compare, both will come to same. These both values are same. These are the addresses. So why they are coming same? Because this P is nothing but the address of A, where the A has been stored. So if you are writing like this, int asterisk Q is equal to address of P, which is the address of this reference variable, and then if you try to print it as well, print F, and you do like this percentile D or percentile U, whatever, then in that case what will happen? Address, you just need to print Q. Q is the address, so Q should print also the same value. Just do like this slash n, so that we can differentiate. So the Q will also come with the same value. I need to use slash n percentile U. Okay, so if I'm using U, then in that case it will give me the correct result. Okay, so you can see that these three values are same, right? For address, you must need to use percentile U, and then only you will be able to get the correct result. So you can see that this pointer Q, which is pointing to the reference variable, and this reference variable, which is pointing to A, both are same, right? So when we create the references, then exactly we are creating a second name, or you can say the alias for a variable, right? So we will discuss more about the reference variables in the next video. Till then, have a nice day and bye-bye.